Hello again, math students. Today we are going to move on talking about exponents, but we're actually going to use some properties, some rules that we have for exponents. You're going to notice in a lot of these sections we've got names for these different rules. This is the product of powers property. A lot of words that begin with P. Property, again, is just a rule. Powers we talked about yesterday, that just means something with exponents. So when we have a product of powers, that means that we're multiplying some stuff that has exponents. So we're going to be talking about rules today when we have some more stuff than just like one thing with an exponent. So for instance, in this table, again, you don't have to copy this table down. We're just I've got all of them written out this time, so I don't have to write them myself. 2 to the second and 2 to the fourth. So I would have 2 of those 2's from this one and then 4 of those 2's from that. So I've got, again, this is the first 2, and then that's the second section that had 4. And I could put all that together from what we did yesterday and say that's really just 2 to the 6th power. In the next one, -3 squared and -3 to the 4th. So I'd have 2 of those -3's and then 4 of those -3's. And how many do I have all together? Well, I also have 6 of those. 7 to the 3rd and 7 to the 2nd. So I'd have 3 of those 7's and then 2 more of those 7's would give me 7 to the 5th power. I hope that you're starting to see a pattern here. 5.1 to the 1st, and I mentioned yesterday, first of all, that I tend to use parentheses when I've got a decimal, but you don't have to have that. And that 1 for an exponent doesn't have to be there, but it does help us in this case to see that I've got 1 of those 5.1s, and then I've got 6 more of them. That would give me 5.1 to the 7th power. Now I've got -4. Notice the parentheses have the negative, so that negative is happening multiple times. -4 squared and -4 squared, so I could write that all out, and then I'd have -4 to the 4th power. 10 to the 3rd and 10 to the 5th, so I'd have 3 10's, and then 5 10's would give me 10 to the 8th. And 1/2 to the 5th and another 1/2 to the 5th. Remember, the parentheses matter for fractions. We need to have that. But if you count all those up, I would have 10 of those 1/2's. Now, the pattern for this property, this general rule that we're talking about is, I want you to notice here the way that they've got this written with these A's. They've got a base of, let me move this down just a little bit if I can, a base of A here and a base of A here. That's just saying some number, but it's going to be the same number. I have some of them, which happens to be M in this one, and then N in this one. I know that sometimes when we start throwing in all these variables, instead of just numbers, it gets a little bit more confusing. But if you would look at, for instance, this one right here, I have the same bases, they're both 7's. Instead of the M and the N, you can see I've got a 3 here, and I've got a 2 here. So what I ended up with was 7 to the 5th power because I added those exponents. That's the rule. If they have the same base, the same thing that's getting multiplied, you add those exponents. So this is another rule now. This is a different rule. For these problems, I want to be able to write this as, this is called a power of a power. Remember, power means something with an exponent. So I have an exponent on something that already had an exponent. Now, I'm going to show you a couple of times with this multiplied out, but then we're going to look for a pattern. The whole idea with exponents is that, again, to save ourselves some time, we don't have to write everything out. 3 squared, that is the thing that's happening 3 times, right? So I'd have 3 squared and 3 squared and 3 squared. Now, thinking back to what we just did in the last slide, I would say I've got 2 of these 3's and then 2 of these 3's and then 2 of these 3's. That gives me 3 to the 6th power. Now I want you to be thinking right now, what could I have done instead of writing all of that out with my exponents to figure out that exponent that I ended up in my answer? Let's try B, and I'll write this one out also. So 2 squared to the 4th power. So that'd be 2 squared 4 times. So this would give me 2 of those 2's, and then 2 more, and then 2 more, and then 2 more. So that would give me a total of 2 to the 8th power. Now, I'm hoping that you're seeing the pattern here, but when we have a power raised to another power, an exponent with another exponent on the outside, we are going to multiply these exponents. Look at what happened here. 2 times 3, that's what gave us this 6. 2 times 4, that's what gave us this 8. Let's try this one with the 7 without having to multiply it all out. 7 to the 3rd squared would be 7 to the 3rd and 7 to the 3rd, so I'd have 3 7s and then 3 more 7s. That's going to be 7 to the 6th power because I multiplied those exponents. So let's use that here. Using a variable instead of a number, who cares? It's a base, right? So this is going to be y to the 9th power. You multiply those exponents. This will be x to the 8th power. So what's happening here as a general rule is when I have an exponent on the inside of parentheses and on the outside of parentheses, I'm going to multiply those. So this would be m times n in this case. And here's our third one. We really have 3 rules today. This one, instead of a power, an exponent on something that already has an exponent, this is a power, an exponent on something that was multiplied, right? So if you'll notice in this one, I've got stuff inside parentheses because I've got some multiplication on the inside. Thinking about order of operations, we would typically have to multiply that first, but I want to be able to write this with exponents instead of just evaluating. When I have 2 times 3 to the 3rd power, this first one would be 2 times 3, and then another 2 times 3, and then another 2 times 3 because it's to the 3rd power. So I really have 1, 2, 3 of those 2's, and then I've got 1, 2, 3 of those 3's. So written with exponents, I have 2 to the 3rd and 3 to the 3rd. I don't really need you to use parentheses here. You could just write it as 2 to the 3rd with a dot, and then 3 to the 3rd. Remember, we're not using x's for multiplying, so make sure that you're careful with that. Based on that one, I'm hoping that you can figure out what b is going to be. 2 times 5 squared. I'd have 2 times 5 and then another 2 times 5. That would be 2 squared and 5 squared. And again, I hope that you see what's really happening here. This is almost, it's not exactly, but almost a distribution. This 3 is going to go onto that 2 and onto that 3, and that's what happened. This 2 went onto that 2 and onto that 5. This 3 is going to go onto the 5 to make it a 5 to the 3rd and a 4 to the 3rd. When I have variables, again, I'm going to say, who cares? It's not a big deal. This would be 6 to the 4th and a to the 4th. And that one doesn't want to go away. I don't know what's happening there. We'll just move it. And then I'll have 3 squared and x squared. Okay? And the rule then for this m, this exponent, is going to get distributed, kind of, onto both of those, which would make it a to the m power and b to the m power. Okay, so here were the 3 rules that we just did. You might want to come back to this slide at some point if you get stuck. But when we have, again, I'm not going to ask you to memorize these names because they all start with P's and it gets a little confusing. A product of powers just means I am multiplying something with exponents. Same bases, we add those exponents. When I have a power of a power, it's an exponent on another exponent, we multiply those powers. So if they're both up here as exponents on the same base, we're going to multiply them. And then a power of products means I had something being multiplied. I've got an exponent out here. That exponent goes on to every part of it. So 3 to the 5th, 2 to the 5th. When we actually have to evaluate, we're going to have to just be able to use those rules, all 3 of those rules, whenever they come up. So in A, I've got 2 to the 4th and 2 to the 5th being multiplied, same bases. Again, I don't care if you know the name of this property, but if they have the same bases, I'm going to add those exponents, which gives me 2 to the 9th. In part B, I want you to notice something that I wrote out. It's very much like A, but I took this original problem and I put this 1 right there, and I want to know where that 1 comes from. And I've mentioned an exponent of 1 before. An exponent of 1 is always on every number that you see if there isn't another exponent there. Again, it's just like having a 1 for a coefficient in front of a variable. If you don't see a number, there's a 1 there. That helps me to see that I had 1 of those -5s, and then I have 6 more of them, which gives me -5 to the 7th power. Without seeing that 1 right there, a lot of people forget about that, and they just leave that as a -5 to the 6th power, so be careful with those. Again, with variables as bases, it's not a big deal. I've got 3 of these x's and then 7 more of those x's, gives me x to the 10th power. In A, I guess on the left side, I didn't number everything, but I've got a power of a power. I'm going to multiply those exponents, so that would be 3 to the 12th power. Here for B, I've got w to the 5th to the 4th power. Again, power to a power, I multiply it. That gives me w to the 20th. And then in these, this is where we've got the product of a power of products, which means I'm going to be distributing that exponent. So this would be 2 to the 3rd and x to the 3rd. And then sometimes today we're actually going to evaluate those also. 2 to the 3rd power, we wouldn't typically leave that. We want to figure out that that's really 8. This time I've got 3 things that are going to get this exponent distributed onto it instead of just 2. But again, I'm going to say, who cares? It's still the same process. So I would have 3 squared times x squared times y squared, and then I would just kind of clean that up. 3 squared is just 9, x squared, y squared. This slide is asking you to leave everything as powers. So this is not a calculator kind of thing. This is just figuring out, do you know what to do with the exponents? So in number 1, same basis, we add the exponents, -6 to the 9th power. Number 2, same basis, add the exponents. Again, I put that 1 in there for the x as an exponent, so I can see that it'll be x to the 10th. Number 3, the parentheses matter, but we've got those 4/5 as bases. I've got 3 of them, and 12 of them gives me 15 of those. -1.5 to the 11th and -1.5 to the 11th is going to be -1.5 to the 22nd. All right, this one's going to have a really big exponent because we've got a power to a power. We've got an exponent inside and outside. Here we multiply that. That'll be y to the 200th power. Number 6 looks messy because of all the parentheses. But the inside parentheses are just to say that it's a -2/9, that's the base. That's to the 8th power, and then that whole thing is to the 7th power. So really what I worry about here, I know that it's going to be a -2/9 for my base. I just have to multiply that power to a power, which is going to give me a -2/9 to the 56th power. Now this slide does not say leave it as powers. Now we're going to be evaluating this, right? So in the first one, I would have 2 to the 6th and a to the 6th, but 2 to the 6th power is going to be 64, a to the 6th. In number 8, I would have, again, dropping my marker, -4 to the 4th power and b to the 4th power. Now, -4 to the 4th power, that will be a positive because it's 4 of those negatives. So that's going to be 256 and then b to the 4th power. In number 9, when I have -9/10 getting squared, -9/10 times -9/10 will be a positive 81 over 100, right? Just squaring the 9, squaring the 10, and then the p squared. Notice that p squared isn't really in the fraction. You can write this as, oops, that one didn't look very good, did it? This would be 81. I can have the p squared in the numerator, but I cannot have it in the denominator. So you can just write it next to the fraction, or you can move it up to the numerator, because this is really something over 1. So we can just move all the numerators together. Number 10. distributing this, since I don't know what the x is and I don't know what the y is, that's just going to be x to the 15th, y to the 15th. Done. Number 11, don't start worrying so much about what 10 to the 5th power is. It'll just be a 1 with 5 zeros, and 10 to the 3rd power is going to be 1,000. It's a 1 with 3 zeros. But this first part, because they're the same basis, I would get 10 to the 8th power. And then I would also have 10 to the 1st to the 8th. I'm going to multiply those exponents, 10 to the 8th power. So I don't really care what 10 to the 8th power is. It's a 1 with 8 zeros. But I'm going to have 10 to the 8th minus 10 to the 8th. I'm subtracting the same things. That just gives me 0. Then for number 12, let's do this. And you could do this quickly in one step. But let me write this out as 7 to the 2nd. And then in parentheses, I would really have 7 to the 8th. Now, this is not a power to a power. They're just the same basis. I happen to have parentheses instead of a dot. But this is going to be 7 to the 10th power, which is real big. Definitely not doing that one in your head, I hope. So today's work is going to be another page from your book, but I have the PDF of the page in Schoology for you, and the answer key is also in Schoology. When you're done, make sure that you take that learning check and let me know if you need any help.